The main purpose of today's discussion is to know how to calculate the pipe friction losses in liquid and gas. So let's start the discussion. Topics of discussion: piping friction loss in liquid, piping friction loss in gas. So we'll see how we can calculate the friction loss in liquid and gas, both the cases. Following steps to be followed to calculate the friction pressure drop or pressure loss for both liquid and gas application. Point number 1. Calculate the velocity of fluid in a pipe segment. Point number 2. Calculate the friction factor, that is using Churchill equation, which is Darcy friction factor. Calculate L by D ratio for the pipe, straight pipe, length of the pipe divided by inside diameter of the pipe. Calculate equivalent LE upon D for the walls and fittings using the data available from the table. Add all the L by D for the pipe plus LE by D for the wall and fittings. So once both L by D and LE by D are available and velocities are known, you can use equation pressure drop is equal to F into L by D plus LE by D bracket close to the V square upon 2G. Input data for the liquid: pipe size and schedule, pipe length, flow rate, operating temperature, density and viscosity, wall types and quantity, fitting types and quantity. Input data for the gas: pipe size and schedule, pipe length, flow rate, gas composition, operating pressure and temperature, compressibility factor, density and viscosity, walls types and quantity, fitting types and quantity. So these data will be required for the liquid and this is for the gas. First number, calculate the velocity of the fluid in pipe segment. So first of all, we have to calculate the flow rate in meter cube per second. Then find out the inside pipe diameter based on the NPS and schedule in meter. Calculate the inside pipe cross section area in meter square. Then calculate the velocity is equal to actual flow rate upon the pipe cross section area. Next step is calculate the friction factor, that is Darcy friction factor, using the Churchill's equation. So Reynolds number, first of all you have to find out, where Reynolds number is equal to RD is equal to RD into V into D upon dynamic viscosity. In case of gas, density needs to be calculated. However, in case of liquid, it is given. Relative roughness, which is equal to small e upon capital D. The small e is roughness of the pipe to be taken from the available table, which is given this side. Churchill equation A is calculated based on the Reynolds number and relative roughness, and Churchill equation B is calculated based on the Reynolds number. Once constant A and constant B is known and relative roughness, then Churchill equation can be used for the calculation of friction factor, which is F into bracket start F 8 upon F is equal to 8 into bracket start 8 upon Reynolds number to the power 12 plus 1 upon A plus B to the power 1.5 bracket close to the power 1 upon 12. Point number 3. Calculate L by D ratio for the length of pipe upon inside diameter of the pipe. So length of pipe is to be find out, that is L, which is meter. Pipe inside diameter is given D in meter. So calculate pipe L by D, just dividing L upon D. Point number 4. Calculate equivalent L by D for the walls and fitting using the data available. So these are the walls and fitting. Corresponding the effective L by D is also given. So for example, if you want to calculate what is total L by D for the ball wall number 1 and a standard elbow 90 degree, which is 4, then total L by D will be 18. 18 is for the ball wall. So into 1 plus 30. 30 is a standard elbow 90 degree into 4. So total will be 138 equivalent L by D. Now add L by D for the pipe plus equivalent L by D for the fittings. So once L by D is added, then next step, calculate the pressure drop using the below equation. So pressure drop in meter will be H is equal to F into L by D plus equivalent L by D into V square upon 2 into G. So if you want to calculate pressure drop in bar, so it will equal P is equal to density into G into H upon 10 to the power 5 for bar gauge, where H is the pressure drop in meter, P is the pressure drop in bar gauge, F is the friction factor which is constant. So L by D plus equivalent L by D is total L by D. V is the velocity in pipe and G is acceleration due to gravity, which is meter per second square. So friction loss in liquid. So let us understand with an example. 400 liter of oil is flowing through 4 inch schedule 40. Inside diameter is 4.026 inch. Commercial or welded steel pipe having length of 6 meter. 04 numbers of standard elbow 90 degree and 1 ball valve are installed in the pipe. Density and viscosity of oil are 8. Please understand 90 degree elbow. It is not written, but let us consider 90 degree elbow. Viscosity of density and viscosity of oil is 850 kg per meter cube and 32 centipoise respectively. Calculate the friction loss or pressure drop in piping. So liquid flow rate is 400 liter, length of pipe is 6 meter, density is 850 kg per meter cube and dynamic viscosity is 32 centipoise. After calculation of effective L by D for the 4 numbers of 90 degree elbow and 1 ball valve, it is coming 138. Pipe inside diameter is 4.026. MOC of pipe is considered welded steel pipe. So pipe roughness is 0.045 millimeter. So a straight pipe L by D is 58.7 and total L by D pipe plus fitting is coming 196, which is 58 plus 138, 58.7 plus 138. Cross section area of pipe is 0.0082 meter square. Velocity of liquid in pipe is 0.81 meter per second and dynamic viscosity in Newton second per meter square 0.03. Reynolds number is coming 2205. Relative roughness small e upon capital E is 0.0004. Churchill constant A is 4.4 into 10 to the power 17. Churchill constant B is 5.0 10 to the power 19. And friction factor as per Churchill equation is 0.0301. So friction loss H is equal to 0.199 meter. And friction factor in bar gauge is 0.017. Now friction loss in gas, let us understand with an example. 25,000 kg per hour of nitrogen flowing through 16 inch schedule 40. Inside pipe diameter 15 inch. Commercial or welded steel pipe having length of 10 meter. 4 numbers of standard 90 degree. It is again not written 90 degree. It should be 90 degree elbow and 1 balls are installed with pipe. Operating pressure and temperature of nitrogen are 1.5 bar gauge and 30 degrees Celsius respectively. Compressibility factor and dynamic viscosity of N2 at operating condition are 0.999 and 0.0099 Cp respectively. Calculate the friction loss or pressure drop in piping. Mass flow rate is 25,000 kg per hour. Pressure is 1.5 bar gauge. Temperature is 30 degrees Celsius. Molecular weight is 28.03 kg per kilomole. Z is 0.999 constant and dynamic viscosity is 0.0099. Length of pipe is 10 meter. Effective L by D for the valves and pit is 138 again for the 4 number of 90 degree elbow and 1 ball valve. So it is coming 138. Pipe inside diameter is 15 inch. MOC of pipe is welded steel, so roughness is 0.045 millimeter. Density of the gas at this operating condition nitrogen is coming as 2.797 kg per meter cube. Cross sectional area of the pipe is 0.114 meter square. Actual flow rate is 2.48 meter cube per second. So gas velocity in pipe is 21.8 meter per second. Dynamic viscosity is 9.9 10 to the power minus 6 Newton second per meter square. Reynolds number is 2.34 10 to the power 6. Relative roughness is small e upon capital D is 0.0001. Churchill constant A is 2.010 to the power 22. Churchill constant B is 1.910 to the power minus 29. And friction factor as per Churchill equation is 0.0131, which is also called Larsen friction factor. So friction loss in pipe F into summation L by D plus L equivalent by D bracket close to the V square upon 2G, which is coming as 51.9 meter, and friction loss in pressure is rho density into G into H upon, sorry, this is mistake again, it should be 10 to the power 5. It is wrongly written, it should be 10 to the power 5. It is not 11000, it is 10 to the 5 for converting in bar gauge. So it is coming at 0.014 is pressure loss. So thank you. With this I have finished my discussion. Hope you will like this. If it is so, please subscribe my channel, like it, share it, so that you will get the intimation of new videos. So see you in the next discussion. Till then, bye bye. Thank you.